about to leave, already packing. Come with me, I'm not really asking. We'll get away to a place where we don't know. About to see the world in action, what we can be, life with no distractions. We'll get away, this is what we waited for. Take my hand, we'll make it somehow. We can't miss out. I'm done living life with the lights out, die with my own doubts. Be free with me. Let's be free with Now looking back, eyes on the freeway, Bonnie and Clyde, a classic cliche. We're on the run, this is what we waited for. Take my hand, we'll make it somehow. We can't miss out. I'm done living life with the lights out, die with my own doubts. Be free.
Good evening, everybody. Welcome to this, our second GCSE Geography study live stream session. We're talking tropical storms, how they develop and why tonight. Warm welcome if you're watching live, and I can see from our little counter down here, we've got loads of you joining us live. And also a big welcome if you're watching on replay, which I know many hundreds of people have been doing in recent times. I'm joined tonight by two of our most experienced and, dare I say it, most popular presenters. We've got Vicky on the left-hand side of the screen.
Hi.
And Suzanne in the middle.
Hi.
Evening, both. How are you?
Yeah, good, thank you. Yeah,
I'm
really
very good. I'm just looking behind Suzanne there, and it looks like you've got a little bit of light left wherever you are, Suzanne. It's not gone quite dark yet, has it? We've still got a little bit of the nice weather left, haven't we?
And thankfully, no tropical storms outside, although I think there's a bit of rain.
Yes, we'll talk weather at the end, perhaps. Well, welcome to everybody. As I say, if you are joining us live, we would really love it if you got involved in our questions tonight. So you've got the chat window on YouTube, which we would love you to use and give us some of our answers. We've got about 30 minutes now of quick, high-intensity activities intermingled with some exam gold advice from our two presenters here. We're going to start off, I think, with one of my favourite activities when I watch these live streams, a bit of red herring. Does that sound right to you two?
Yeah, yes it does.
Right, well, let's get started.
Okay, welcome to tonight's session. So like we said, it's our second study stream looking at those tropical storms. We're going to talk about where they occur. We're going to talk about why and how they form. We're also going to put a bit of global atmospheric circulation as well, because we know you find that quite tricky. So we are kicking off tonight's proceedings with the red herring quiz. 3 of our fish on the screen have something in common. You need to spot the odd one out and what connects the others. So can we have the first one up, please, John? Excellent. So in front of you, you have 4 fish: hurricane, tornado, cyclone, and typhoon. So you just need to work out what is the red herring and what connects the other 3 fish. If you can just pop the letter of the red herring into the chat window, we'll give you a few seconds. And then if you can tell us what the others have in common, that would be absolutely brilliant. I'll give you a couple of moments just to pop something into the chat window. Excellent. So we have super. We've got some correct answers coming through now. So C is the red herring. Tornado is our red herring. The others are all tropical storms. Well done. So lots of students quite often get confused about and sort of call out tornadoes as tropical storms. They're not. It's a funnel of a violently rotating wind, which I think is what gets the confusion there. When they're formed when warm, humid air collides with cold, dry air. They don't need to be in tropical areas, though. And most of them actually occur in the USA because of that warm, moist air from the Gulf of Mexico and the cool, dry air from Canada. Right, we have one more red herring. So if we can have the next one up on the screen, please. Super. So we have Haiyan, we have Irma, we have Ida, and we have Matthew. So which of those is the odd one out and what connects the other 3? So again, can we have them popped up? So a question in the chat window saying, can this be downloaded and watched later? Yes, it can. It will be available to download on the Tutor to You on demand page straight after we have finished presenting. Okay, so what do we think is the odd one out in this case? So we've got one incorrect answer that's come up at the moment. Actually, it's come up twice now. Okay. So we have quite a few people think that Matthew is the incorrect answer. Matthew is not actually the incorrect answer. So perhaps that's just a storm that you come across. See, Ida's quite a recent storm. Irma is a really big, famous one that some of you will have looked at. Okay, so again, we've actually got 3 wrong answers, but we do have the correct one. We have Haiyan has just come up A. So Haiyan is the red herring for 2 reasons. Firstly, it is although it's a tropical storm, it's actually a typhoon. It hit the Philippines and Southeast Asia. My students, myself, are currently studying Haiyan in year 10. It occurred in November 2013. So the others are all hurricanes within the last 5 years. Many of you will actually study Haiyan as your extreme weather event, I imagine, for a low income country. Okay, can I hand over to Suzanne now, who's going to talk you through what we're going to cover this session.
Fab, thank you very much, Vicky. Right, so I'm going to just talk through our introduction to this session. Tropical storms actually appear on paper 1 in the Challenge of Natural Hazards unit, and it'll always be question 1 on the paper. Now, this actually sits alongside the work that you have done on plate tectonics, so your volcanoes and earthquakes, and also your climate change topic. Within this section, the key knowledge you need to have is where tropical storms form and develop. And actually, as we heard Vicky say, where they form actually affects their name. So those tropical storms that form in the Atlantic Ocean are called hurricanes. The tropical storms which form in the Indian and South Pacific Oceans are called cyclones. And if a tropical storm forms in the west of the North Pacific Ocean, like Haiyan there, it's called a typhoon. You also will need to know some of the reasons why they form here and the role of the global atmospheric circulation model, which I'm going to be talking about a bit later. And that redistributes the heat. The causes of tropical storms you need to know, and the sequence in their formation and development, which I know Vicky's going to go through a bit later. And also, and this will be in next week's session, a named example of a tropical storm to help you know about the primary and the secondary effects, and also the immediate and long-term impacts. And yeah, so the things that happen directly when the tropical storm hits. That's the primary effects, and then the secondary effects, the after effects that occur as indirect impacts of the tropical storm. Right, I think we have a quick quiz now. Oh, no, we don't.
No,
do we?
No, we don't. No,
we don't. Okay.
One in a minute.
I'm going on to here. So we're just going to have a look here at some of the key things that affect. No, this is, sorry, Vicky, I'm jumping in. This is you, isn't it?
You're just stealing my bit.
I am so sorry. That's why I was a bit confused. I will leave this one to you.
Okay, so we're going to have a look at what the process kind of along the equator. So hopefully we all know that latitude is the most important influence on the global variation in climate. So we again should know that that's because the equator receives much more solar radiation than the other latitudes, and that's due to the curvature of the Earth. So the sun's rays hit the equator directly, they are much more concentrated, whereas towards the poles those rays hit at an angle, so the radiation is spread out much more. This means that air along the equator gets heated more, which hopefully then sort of begins to make sense as to why we get those tropical storms fairly close to the equator. So that heated air is much less dense, so it rises up, forming that area of low pressure that we need to form all of those clouds that we get. Those clouds are a vital ingredient of tropical storms because obviously they are what brings those huge amounts of water, that huge amounts of rainfall that you see coming in with those hurricanes in particular. So after rising, the air begins to spread out and it starts to flow towards the poles. And Suzanne will talk about why that happens in a moment. That's about the global atmospheric circulation model, which hopefully you again are relatively familiar with, although it is quite complicated. So the poles are an area of high pressure as they receive much less solar radiation to make air rise. So that air, so again, this is we've talked you through this. It's much briefer on the slides in front of you. Remember, you can download these slides, but you just need to know that the equator receives that greater concentration of solar radiation in the poles because of the curvature of the Earth, because that air is heated more, making it less dense, it rises up and it creates that low pressure at ground level, which is where we get all of those clouds from. A bit later in the session, we're going to talk to you about how those tropical storms actually form in the area close to the equator. So I'm going to hand over to Suzanne now, who has a quick Give Me 3 activity, which is then going to lead us into our next discussion point.
Brilliant. This is the one I thought I was up with. Right, so what I would like you to do, please, and you can put this in the chat box, is see if you can recall the names of the cells that join together to form the overall circulation of the Earth's atmosphere. So I'm looking for 3 different names. Okay, I shall be looking in that chat box to see who's the fastest typer. So have a recall of those 3 cells. Whoa, Sheely, well done. Fantastic. Hafsa, I've got one there. Brilliant. Well done, Luca. Teresa, brilliant. I've got some good, some very quick answers there. Lots of you, I'm sure, are doing your revision on this. Wonderful. Right. Can we reveal, please? Oh, sorry, we've still got the 30 seconds going. I'll wait. Right. Thank you very much. So we had so many correct answers there. So the first one there is the Hadley cell, which I'm going to be talking about in a minute, feral cell and the polar cell. So if we can have a look at the next slide, because I think the next slide should have my global atmospheric circulation model. Fantastic. Right. So we're going to be having a look at this model. It might be familiar to you. You might have seen it in class. Your teachers might have given it to you. You might have even drawn it out, maybe on a paper plate. But this model helps to show us how the patterns of atmospheric pressure and winds supports an understanding of where climatic regions are and also the weather patterns, which of course is what we're really interested in because we want to know how do they end up being involved in tropical storms. But also this model is actually really good at supporting your understanding of where different climate zones are for your living world unit for paper 1 as well. So it actually kind of kills 2 birds with 1 stone, this model. So we're going to start off by thinking about that driving force behind the Earth's global atmospheric circulation. And as Vicky said, we have to consider the sun and how the sun's energy, or the solar radiation, is actually unequally distributed between the poles and the tropics. And because the Earth's atmosphere and its oceans are constantly moving around, they're redistributing this heat. So basically, the global atmospheric circulation model is driven by this imbalance in the sun's energy, or sometimes we call it differential heating. So Vicky told us about how the latitude of a location was a really big influence on the climate and how much solar radiation it was actually receiving. And obviously on the equator, as we heard, where it's a much more concentrated solar radiation, this is where the air warms and it rises because it's less dense, and it creates a low pressure belt on the ground level. And we're going to take some of these ideas and actually develop them further to help understand our global atmospheric circulation model. You can see here on this model that there's actually 3 cells operating, and I saw how well lots of you were in recalling the names of those 3 different cells. And they operate in what's called the troposphere, which is the lowest layer, which is where most of our weather occurs. But why do these 3 cells exist, and what really happens within them? That's the sort of question we have to ask ourselves as geographers. And the Hadley cell you can see here, and that's going to be the really important one to us as looking at tropical storms, is between 0 and 30 degrees north and south of the equator. And as we heard, at the equator, the insolation, that's the amount of solar radiation that reaches the area, is at its most concentrated. So the air is superheated, it becomes a lot less dense, and it rises, and it begins to create that area of low pressure in the lower levels of the troposphere. So remember that lower level that we're talking about, which ends up about 10 to 15 kilometres above the Earth's surface. And that low pressure is caused by the ascending air. So as the air rises upwards, it leads to a lower pressure on the surface. Now, I think maybe your teachers might have covered this, but it's really important to understand that if the Earth wasn't spinning, this air would actually rise from the equator and it would move all the way to the poles. But because the Earth is rotating, that simple circulation of one cell actually gets split down into the 3 cells in the northern hemisphere and those 3 cells in the southern hemisphere. Right, could I have the next slide, please? So, we are back to, I think, our Hadley cell I'm going to be talking about here. So that first cell, 0 to 30 degrees north and south. So we have the air at the equator rising, it cools and it condenses. And you can see there, it forms towering cumulonimbus clouds. That's quite a mouthful. And they are really the very large storm clouds, which can cause really severe thunderstorms, particularly in those equatorial regions. And of course, they're the ones that produce the heavy rainfall that we need in the tropical rainforest biome, all of which are located along the equator. So there's your link with the living world and tropical rainforests. So as that air continues to rise to the edge of the troposphere, it moves towards the poles in a north or a south direction. And the cooler air will descend when it reaches about the tropics, up to about 30 degrees north or 30 degrees south of the equator. And as the air begins to descend or sinks, what it does is it creates a high pressure zone. And that descending air warms because there's no condensation or rain within it. So it actually produces a warm and a dry climate. But of course, that matches the global distribution of deserts. So again, another link with your living world unit. The air that is descending, that higher pressure air, returns as a surface wind back down to the equator, and that completes the cell. But as you can see from that final bullet point there, These are called trade winds. But under the Hadley cell, the returning air is not going back sort of in a straight direction. It's actually deflected by the Coriolis effect. You might have heard about that. It deflects winds. So in the northern hemisphere, the air returns, and they're called the easterly trade winds as they blow from the east. And those surface winds blowing from the tropics to the equator are dry. So they also affect the countries which they blow over. And actually, trade winds, any of you who do history or might have done it at Key Stage 3 will know that actually trade winds have played a massive, vital role in our maritime history and sort of movement of the British Navy across the world, and also trading. And it's really important because they're the trade winds that help cause tropical storms to blow from east to west. Right, I will, do my true and false now. So we've got true or false. Again, if you can put into the chat box, please. Solar radiation is highly concentrated at the equator, causing air to rise, creating a low pressure zone. Is that a true or is that a false? If you can pop your answers in the box. Whoa, quick. Yeah, some good quick ones here. Fantastic. Yeah, got loads of correct answers there. Right, can we have the reveal, please, John? Wonderful. So that is in fact true. Of course, we said warm air rising creates a low pressure zone. Right, and our next true and false. So as air rises and cools above the equator, it forms wispy cirrus clouds. What do we reckon there? I'm waiting on that chat box. Oh, I can't work out which ones that. Oh, I've got some retracted. Yeah, I've got mix here. Mix. Did you not hear me stumble over the name of the cloud? Right, John, can we have the answer, please? It's false. They were the towering cumulonimbus clouds I talked about. They're the ones that create the big, severe thunderstorms. Right, okay. Thank you. I think, are we back over to you, Vicky?
Yeah, we are indeed. Thank you very much. So the last thing that we're going to discuss this evening is how tropical storms actually form. So we've talked about where they are and why they are where they are, but you also need to know how they form. So tropical storms are simply a spinning mass of clouds. About 80 to 100 occur every single year. So we compare them by giving them names. So quite often students ask, why do they have names? Well, they have them because they always sort of occur in the same place. We need to know what they're called so we can compare them. And the first storm of the year usually starts with an A, then a B. They tend to alternate between male and female names. They quite often have quite strange names. So in 2017, we had Harvey, followed by Irma, followed by Jose, which begins with a J. And they tend to be chosen in advance, which wasn't something I was aware of until I did a bit of research for this a couple of weeks ago. And the names used for really devastating storms are not reused and never used again. So these tropical storms occur within the tropics between 3 and 30 degrees north and south. They do not actually occur at the equator. And this is because of the Coriolis effect. So Suzanne talked about that a moment ago. It's the idea, it's the effects of the Earth's rotation. But at the equator, the Coriolis effect itself isn't actually strong enough to make that storm spin. So they don't actually happen along that line of the equator. It's generally 5 degrees above and below, and that's where you see those tropical storms up until 30. So here the sea temperature needs to be at least 27 degrees. That's a number that you really, really need to remember, which is close to the temperature of a heated swimming pool if we're kind of trying to put that into context. And it's why we don't get them in the UK. So quite often students ask if we ever get them in the UK. Well, the maximum sea temperature in the UK is generally about 17 or 18 degrees. So we are a long way off getting hurricanes or cyclones or typhoons, obviously. The sea temperature needs to be also at a depth of 60 to 70 metres deep. And this provides the heat and the moisture that is needed to cause that warm air to rise rapidly, which creates that low pressure that we have talked about before. So winds start to spin due to that Coriolis effect, the effect of the Earth's axis that we've already mentioned. And that rising air will cool and condense to form those tall cumulonimbus clouds that we talked about a moment ago when we were discussing global atmospheric circulation. As this happens, we actually get a release of latent heat, and that's basically that's energy that's released without a change of temperature. And this actually powers a tropical storm. So you're going to have lots of low winds present that allow that tropical storm clouds to rise high, but they're not strong enough to rip that tropical storm apart. Okay, if those winds around the edge were stronger, then that tropical storm would just get ripped apart. Right in the centre, most of you will be really aware that there is an eye of the storm, and this is a really calm area. The conditions are completely calm. You can see it on the screen in front of you. On tropical satellite images, when you see those storms swirling around, you often see the eye it's just there in the middle. The eye can be really, really big, so it can be huge areas, lots and lots of meters across. This eye is formed by the cool air sinking, and that creates that zone of high pressure where we don't have clouds, where we know hopefully that high pressure leads to nice settled weather. The storm then gets steered by trade winds towards the land, and once it makes landfall, that energy will start to subside. And again, hopefully we understand why that happens. The reason it happens is because it's lost its source of power, the source of power being that nice warm sea temperature. So most of the tropical storm damage then therefore occurs along the coast. And it's quite easy to track tropical storms again as well, so you can kind of see where they're hitting. Occasionally, tropical storms might bounce out to the sea and get a bit more energy. Sometimes if they're travelling across islands, once they pass the islands, for example, the ones that hurricanes in the Caribbean that then go on to hit the USA, they will come across the Caribbean islands. Then once they've cleared them, they will pick up a little bit more energy before they start to batter the coast of Florida, for example. But they don't travel very far inland because they lose their power quite quickly. John, can we have the next screen up, please? Okay, so again, you can see that tropical, that hurricane formation diagram on the screen here. And again, lots of you will have seen this. Lots of you will have drawn it out in your lesson. So you can see the air sort of rising up and you can see it starting to spin around there. Okay, I've already talked about what's on the screen in front of you, but like I've said, at the end of the session, you can download the PowerPoint, you can pause, obviously, if you're watching it on replay, you can have a read through the things that we've just been talking about. Can we move on to the next activity, please, John? Thank you very much. So we're going to rearrange these scrambled sentences to explain how a tropical storm forms. It's quite tricky in the time that we're going to give you in the live session. If you're watching on playback, you might want to pause it and give yourself a little bit more time. So in the chat window, what we would like is just the numbers in the correct order in that chat window. So we're going to give you a minute or so to have a look at them. I'll read them through. They are currently in the incorrect order, but hopefully you've listened to what I've just been talking about. It hopefully makes a little bit more sense now, and you should be able to put it in the correct order as a result. So at the top, we have the storm is steered by the prevailing wind. On reaching land, the storm loses power. Its source of power, and it weakens. The friction also slows it down. With rising air cools and condenses to form tall cumulonimbus clouds. That latent hidden heat is released with condensation further powering the storm. The winds start to spin up due towards the Coriolis effect. The air is heated above the surface of warm tropical oceans. The cold air sinks in the eye, creating calm, dry conditions. And this warm air rises rapidly, drawing more air and large volumes of moisture from the ocean, causing strong winds. So can we have a go? It is a really tough one. You just need to put the numbers in. But we appreciate that it's quite a big ask in quite a short period of time. So this is probably a better one for those of you that are watching on demand, because obviously you can pause it and give yourself as much time as you need. However, we do have some people who have had a go. So far, everybody is in agreement, has them in the same order. We'll have a look in a moment and see whether you are correct. I'm going to give you another 10 seconds to see if we've got anybody else coming through. Excellent. So far, every single person coming through has the same order. So, John, can we have the correct order up on the screen and see whether you are correct? So we have 5, 7, 3, 4, 6, 1, 2. Well done. So Charlotte, Windows 1112, Ethan and Luca, all correct. Okay, and we've other people all coming through. Well done. So that air is heated above the surface of the warm tropical oceans. We've talked about that already. The warm air rises rapidly, drawing more air and large volumes of moisture from the ocean, causing strong winds. The rising air cools and condenses to form those two tall cumulonimbus clouds. The latent hidden heat is released with the condensation further powering that storm. The winds start to spin up due to the Coriolis effect. The cold air sinks in the eye, creating calm, dry conditions. The storm is steered by the prevailing wind, and on reaching land, the storm loses the source of its power and it weakens. Friction also slows it down. Well done, guys. Really good work there, getting that into the correct order. Right, I'm going to hand over to Suzanne for some quick exam practice, and then after that, we've got one last short activity, and then we are done.
Thank you. And I just want to say how impressed I were at how quickly some of those people at home got that. So I hope those watching on catch up, you're managing to work out which way they are too. Right. Okay. So exam gold. This is exam practice. So each week we're going to show you some exam practice questions, and we're going to consider how this type of question could be answered. So this week, here's our question. It's give 2 reasons why tropical storms form between the Tropic of Cancer and the Tropic of Capricorn, and this is a 4-mark question. So here we have the command word give, and this means, according to AQA, produce an answer from recall. So we're quite good at that as geographers. So this is actually assessing assessment objective 1, which is your knowledge and understanding, that recall bit, and also it's going to be assessing AO2, which is your understanding of concepts and processes in relation to processes. And really, for this type of question, we're going to need at least 2 reasons, and these need to be well-developed points. So things to remember. I think this is on the next slide, John. Things to remember and things to think about. So remember, of course, Vicky told us that tropical storms form between about 5 and 30 degrees north and south. And we know that they can't form directly on the equator because the Coriolis effect is not strong enough to help them spin. So that's something to have at the back of our minds when we're thinking about why they're between the Tropic of Cancer and Tropic of Capricorn, because actually there's a little gap around the equator where they can't form. So you can see that it says, think about the climate along this zone and what's it like. So as we talked about, tropical storms are found in the tropics, as this is where that Hadley Cell, remember, not so long ago, I was talking about the global atmospheric circulation model, and that influences the weather and climate in the tropics. So the Hadley Cell, of course, was creating those low pressure systems near the equator, and the climate there was characterized by rapidly rising warm air, which then cools and condenses, forming thunderclouds. And that, of course, is what we need to form tropical storms. The condensing water vapor releases that latent heat and powers those storms further. So when several of these thunderstorms meet together along those tropics areas, they're much more likely to form into a tropical storm. The role of the ocean, as you can see there, is also vital, absolutely vital, because tropical storms require that constant supply of moisture and the transfer of heat from the ocean. And Vicky explained to you about the fact that they needed very specific ocean conditions of over 27 degrees centigrade to form. And of course, that's really strongly linked to the latitude, because the amount of solar radiation that's being received by the oceans is going to be highest closest to the equator. We also need that depth of between 60 and 70 metres. So when we're looking at where they might be forming, we're making sure that we're looking at some of those locations that are equatorial and have a vast expanse of ocean, because that warm water is at the very heart of tropical storm formation, and the evaporation and the condensation that occurs drives its formation. And once the tropical storm, of course, passes over land, that's when the source of the moisture driving the storm is removed, so the storm weakens, and also the friction from the land slows it down. Right, and finally there you can see the bullet points is rising and cooling air is also really key to tropical storms forming in those tropics. So that warm, moist air above the sea rises up and it draws in more fresh, warm, moist air near the surface. And of course, it's deflected at the same time by the Coriolis effect, causing the system to begin to rotate. As that warm and very humid, moisture-laden air continues to rise, it cools extremely rapidly until the clouds are formed and they release their latent heat. And that's where water turns from a gas into a liquid, which really, really helps fuel that storm. Okay, so there's some things that you would consider when looking at this question. Okay, right. So here we go. These are some key vocab that you might want to be using when talking about tropical storm formation and distribution. So it's really important to make sure you mention the role of latitude and how much receipt of solar radiation is being received by the equator. Remember that differential heating and the fact that oceans near the equator have much higher insulation. The global atmospheric circulation model. Remember that Hadley Cell and how the process of rising and cooling air along with the Coriolis effect contribute to the tropical storm formation. And lastly, you can include specific details. Recall these, the things about the temperature required, 27 degrees centigrade, the depth, so between 60 and 70 meters of sea at that temperature, and also the types of clouds. And again, I'm going to say it, cumulonimbus clouds. Okay, I think that is over to Vicky.
Okay, well done for keeping up. Obviously, we've covered lots and lots of stuff today. We've got one quick quiz at the end. So 3 10-second countdown challenges. You'll have 10 seconds to answer the questions on the screen. These ones are quite easy because I think we've kind of pretty stretched your brains. Made your brains maybe hurt a little bit this evening. So we're going to have 10 seconds to answer these quick questions on the board. So the first one, which ocean or oceans are hurricanes found in? So can we have the timer, please, John?
10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have ignition.
Okay, at the moment, so we have some interesting answers coming up at the moment. If we can have that answer on the screen, please. So they are found in the North Atlantic, East Pacific. So they generally are around the Americas. Okay. So can we have the next one up on the screen, please? So which ocean or oceans are cyclones found in?
Liftoff will start in T-minus 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have ignition.
Okay, so we have some answers coming through on the chat window. Let's see if you are correct. So they are found in the South Pacific and the Indian Ocean. Well done, those of you who got that correct. And our last one, you'll probably guess what this question is. Which ocean or oceans are typhoons found in?
Liftoff will start in T-minus 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have ignition.
Well done. We have some correct answers coming through. We've also got a couple of incorrect answers coming through, but they are the correct answers for the last one, so they could just be delayed answers. They are found in the Northwest Pacific. Well done. Can we have the final screen up? Thank you, John. So hopefully this has been really useful for you this evening. There are lots of further resources, study notes and revision support and all sorts available on the Tutor2U website. You can follow the you could go to teachertoyou.net, or you can follow the QR code on the screen. We've also got some very good study books as well, which cover the entire Living with the Physical Environment unit, which obviously this is part of. Please join us next week when we are going to be looking at the effects and responses of tropical storms and tectonic hazards. So we'll see you there at the same time.
Wow, thanks ever so much, Vicky. Well, and to Suzanne as well. Well done to everybody who has answered all the questions tonight. I had a go at answering some of the questions. I wanted to make sure that I was in the crowd. Cumulonimbus. Have I got that right?
Yeah.
I know, I think I had to say that 4 times, John.
Brilliant. Well done. I tried to jot down a few names as people were answering questions. Shuli, Ethan, Lucas, Sophia, well done. Charlotte, I think, was the quickest with the scrambled sentences, which I thought was a really tough question to have a go at. So well done to Charlotte.
Really tough.
Massive thank you to Vicky and Suzanne for presenting tonight. Some really interesting, superb stuff that's going to be very valuable, I'm sure, to students taking their GCSEs later on. If you've enjoyed tonight's session, please give us a thumbs up. If you haven't enjoyed tonight's session, then please give us a thumbs up. It all helps when it comes to indicating to other students who are trying to do well in their GCSE in geography where to go to get superb information on information like we've had tonight, tropical storms. Vicky, did you say? I was trying to listen. What is the next tropical storm that we're having? Have we got a name already?
I don't. There will be a name already. I don't know the name already, but they have apparently a long list that they prepared the year before.
Always interesting stuff to know, that one. Okay, brilliant. Thanks ever so much. Hopefully we'll see you next week as well for a bit more GCSE Geography live stream study. Goodbye, everybody.
Bye.
Bye.